It's not often you come across someone who doesn't just answer the big questions, but kinda, like changes the questions we even think to ask.
Right.
That's the kind of mind we're grappling with today. We're going deep, deep into the world of Sir Isaac Newton, a guy whose fingerprints are all over, well, pretty much everything.
Yeah.
From how we understand the way things move to the math we use to describe it.
Talk about a scientific revolution in one person. It's hard to even wrap your head around it. I mean, the laws of motion, they're like physics 101, right? And calculus, it's the bedrock of so much of modern science and engineering. Oh, and then there's light.
Yeah, let's not forget his work on light. Seriously, sometimes you have to stop and just marvel that all this came from one mind.
Absolutely. And we've got a whole stack of material to dig through. Mainly his Wikipedia page is pretty massive.
It is. But our mission, if you will, is to sift through it all and pull out the real gems. The insights into Newton's life and work that'll leave you, feeling smarter, but not totally overwhelmed.
Exactly. We're not just after the basic facts. We want the good stuff, the juicy bits, the stuff that makes Newton so fascinating and, frankly, kind of weird.
All right, so let's rewind the clock way back. Isaac Newton enters the scene on January 4th, 1643. At least that's according to our modern calendar, the Gregorian one.
But there's a little twist.
Oh, there's always a twist.
Back then, England was still using the old Julian calendar. So according to that, his birthday was actually on December 25th, 1642, Christmas Day.
Wow. Talk about a significant birth date. The guy who would redefine our understanding of the universe, born on Christmas.
Right. It's almost poetic. And speaking of beginnings, his wasn't exactly easy.
No, not at all. His father, he died just 3 months before Isaac was born, and Newton himself was premature.
Tiny, in fact. His mother used to say he was so small he could fit inside a quart mug.
A quart mug. That's incredible.
Yeah.
From a quart mug to one of the most influential minds of all time.
That's Newton for you. But the early years, they weren't all sunshine and roses. When he was just 3, his mother remarried, a clergyman named Barnabas Smith.
Ooh.
And, she moved in with her new husband and left young Isaac with his grandmother. Not exactly a recipe for a happy childhood.
I can imagine. It sounds like it left some scars.
Definitely. He seems to have held a lot of resentment towards his stepfather and even his mother. There's this chilling entry in a list of sins he wrote as a teenager, threatening my father and Mother Smith to burn them and the house over them.
Oh, wow. That's intense. It really gives you a glimpse into what he was carrying around.
Yeah, it's heavy stuff. Anyway, he finally started school around age 12 at the King's School in Grantham.
Okay.
And that's where he really got into Latin, ancient Greek, and of course, math. But even his education wasn't a straight line. His mother, she was widowed again by then, pulled him out of school to run the family farm.
Really? Isaac Newton the farmer. Somehow I don't picture that.
It didn't go well. He hated it. Thankfully, the headmaster at the King's School, a guy named Henry Stokes, saw how bright Newton was and convinced his mom to send him back.
Good call, Mr. Stokes. So back to school he goes. And there's even a story that part of the reason he wanted to go back was to get revenge on a bully.
Oh, yeah. Classic schoolyard drama. Even geniuses have rivalries, I guess. Anyway, he eventually made it to Trinity College, Cambridge. But even then, things weren't easy. At first, he was a subsizer. Basically, he had to work odd jobs like being a valet to help pay for his studies until he got a scholarship in 1664.
Wow. Talk about driven. He really wanted that education. So what was Cambridge like back then?
Well, the main curriculum was still all about Aristotle and the ancients. But Newton, he was hungry for new ideas. He devoured the works of Descartes, Galileo, and a guy named Thomas Street.
Those are some heavy hitters in the world of science.
Absolutely. And Newton, he was grappling with all these new concepts in a notebook he called Questions. He was particularly interested in something called mechanical philosophy.
Mechanical philosophy.
Yeah, it's the idea that the universe basically runs like a giant clock. Everything operates according to these set physical laws.
I see. So it was during this time that some of his most revolutionary ideas started to germinate.
Exactly. Even before he officially finished his degree, he was making groundbreaking discoveries. In 1665, he had this major breakthrough. He figured out the generalized binomial theorem.
Okay. I have to admit, math isn't really my forte.
Basically, he figured out how to apply the binomial theorem to powers that weren't whole numbers. It was a huge step towards his later work. And, get this, he also started developing his early ideas about calculus around this time.
Calculus. Yeah, that one rings a bell. Didn't that cause some controversy later on?
We'll get to that. But first, there's this twist of fate. Just after Newton got his Bachelor of Arts degree in 1665, the Great Plague hit England.
Oh, right, the plague. Not exactly a fun time in history.
Cambridge shut down, and Newton went back to his family home in Woolsthorpe, and that's when things really took off.
Really? So this forced isolation actually boosted his creativity?
Yeah, big time. These 2 years are considered one of the most productive periods in the history of science. The physicist Louis T. Moore even said, and I quote, "There are no other examples of achievement in the history of science to compare with that of Newton during those 2 golden years."
Wow, that's high praise. So what exactly did he achieve in those 2 years?
Well, he laid the groundwork for calculus. He had those fundamental insights into the nature of light. And get this, the seeds of his law of universal gravitation, they were planted during this time too.
I mean, that's just mind-blowing. It's like being locked up unleashed some kind of intellectual superpower in him.
It's remarkable. And, Newton was a meticulous note-taker. He even made alphabetical indexes in his books.
Alphabetical indexes, that's very organized.
He was a very organized guy. And this ability to connect different ideas from, different fields, it's what made him so brilliant. He's been called a Janusian thinker. Janus, the Roman god with 2 faces looking in opposite directions.
So Newton could see connections other people missed.
Exactly. Anyway, when Cambridge reopened in April 1667, he went back and was elected a fellow of Trinity College.
Okay, so he was back in the academic saddle.
Yes, but there was a catch. Being a fellow meant you were supposed to become an Anglican priest. And Newton, well, he had his own, shall we say, unique take on Christianity.
Oh, right. I remember reading something about his religious views being a bit unorthodox.
To put it mildly, by the 1670s, it was clear that his beliefs clashed with official church doctrine, and this created a real problem for him.
Yeah, I can see how that would be tricky.
Fortunately, fate intervened. In 1569, the Lucasian professor of mathematics at Cambridge, Isaac Barrow, decided to step down. He wanted to focus more on his religious studies.
And that opened the door for Newton.
Exactly. At the ripe old age of 26, Newton was appointed the new Lucasian professor.
Wow, 26. That's incredibly young for such a prestigious position.
I know, right? But Newton, ever the clever one, argued that this job should exempt him from having to become a priest. And amazingly, King Charles II agreed.
So he basically got a royal pass to skip the whole ordination thing.
Yep, pretty convenient, huh? It allowed him to keep doing his groundbreaking work without having to compromise his conscience. And speaking of work, being the Lucasian professor wasn't all about complex math.
Oh, what else did it involve?
Well, believe it or not, he was also supposed to teach geography.
Geography?
Yeah.
Seriously. It seems like a bit of a mismatch for someone like Newton.
You'd think so, right? But, being Newton, he actually revised and published a geography book by Bernhardus Varenius called Geographia Generalis. It happened twice, first in 1672 and then again in 1681.
So even in a subject like geography, he left his mark.
Oh, absolutely. Varenius's book was a big deal back then. It tried to combine scientific principles with more traditional ideas about the Earth. It was all about making geography more systematic, more mathematical.
I see. So Newton, being Newton, took it and made it even better.
Exactly. And even though we don't know for sure if he ever actually lectured on geography, his involvement in the book gave it a lot of weight. It's actually seen as a bridge between ancient and modern geography, all thanks to Newton's input.
Wow, that's quite a legacy. And his star continued to rise, right?
Oh, absolutely. In 1672, he became a Fellow of the Royal Society.
Ah, the Royal Society, the big leagues of science back then.
Exactly. It was a clear sign that Newton was one of the leading scientific minds of his time.
Okay, so let's talk calculus. It's one of his biggest achievements, right?
Okay. Without a doubt. Newton started working on what he called frictions around 1664. And just a couple of years later, in 1665 and 1666, he had already figured out the main ideas behind calculus. Calculating tangents, areas under curves, stuff like that.
So he was basically inventing a new way to describe how things change.
Precisely. He was coming up with a whole new mathematical language, and he documented all his early ideas in these manuscripts. One from October 1666 is particularly important historically.
So this is where things get a bit messy with Leibniz.
Right. You got it. The big calculus controversy. Now, both Newton and Gottfried Wilhelm Leibniz are credited with developing calculus independently. They each had their own approach and notation, But
Right.
the historical evidence pretty clearly shows that Newton was actually the first to figure out the core concepts, like years before Leibniz.
But didn't Leibniz notation end up being more popular?
True. Leibniz's notation, with its didactics and the integral sign, it just turned out to be more practical, more user-friendly. Even British mathematicians eventually adopted it. But, that doesn't take away from Newton's achievement.
So was this a big public feud? Did they throw shade at each other in scientific journals or something?
Well, there was definitely a lot of tension. The historian A. Rupert Hall summed it up well. He said that while Leibniz deserves credit for coming up with his version independently, Newton was, without a doubt, the first one to truly master the techniques and ideas of calculus.
But if Newton figured it out first, why didn't he just, publish it and claim the credit?
That's the thing about Newton. He was incredibly reluctant to publish his work. He had this almost paralyzing fear of criticism, and that hesitation, unfortunately, fed into the whole priority dispute.
So did he ever actually use calculus in his own work?
Oh, absolutely. He used it extensively in the Principia, his masterpiece on physics, but he presented it in a geometric form, using what he called the method of first and last ratios. He even explained that this method was just as rigorous as his more analytical techniques.
Interesting. So he was kind of like hiding calculus in plain sight.
In a way, yes. And you know what's even more fascinating? Some modern scholars, like the physicist Roger Penrose and the mathematician Vladimir Arnold, they've actually argued that Newton's geometric methods were incredibly insightful. They say they reveal deeper principles than the more formal calculus that came later.
That's a thought-provoking point. So this whole Leibniz controversy, it went beyond just the two of them, right?
Oh, yeah. It got pretty nasty. There's this Swiss mathematician, Nicolas Fatio de Douillet, who was a close friend of Newton's. And Douillet, he publicly accused Leibniz of stealing Newton's ideas. That really fanned the flames of the controversy. It dragged on for years, with both sides throwing accusations around.
So how did it all end?
Well, the Royal Society formed a committee to investigate, and guess what? They declared Newton the winner.
Case closed, right?
Not so fast. It turned out that Newton himself had actually written the final part of the committee's report.
Oh, come on. That's not exactly playing fair.
Yeah, not a good look for Newton. But controversy aside, his mathematical contributions were vast. Beyond calculus, there's the generalized binomial theorem, Newton's identities, Newton's method for finding roots of equations.
Okay, I get it. The man was a mathematical genius.
And that's just scratching the surface. He made strides in classifying cubic plane curves, contributed a ton to the field of finite differences. Some even call him the most important figure in that area. He stated Bézout's theorem, a fundamental idea in algebraic geometry. He was a pioneer in using fractional indices and power series.
Okay, you've made your point. He was prolific. And let's not forget his work on optics. I mean, the guy practically reinvented our understanding of light.
Absolutely. Back in 1666, during that super productive time at Woolsthorpe, he had this key insight. He passed sunlight through a prism and noticed that the spectrum of colors wasn't round, like the original beam, but oblong. That led him to this revolutionary idea.
That white light isn't actually pure, but is made up of all the colors of the rainbow.
Bingo. It blew everyone's minds at the time. It challenged centuries of thinking about light. Between 1670 and 1672, he gave lectures on optics at Cambridge, elaborating on his findings. And he even showed that you could recombine the spectrum back into white light using another prism and the lens.
So he took light apart and put it back together again.
Exactly. Oh, and there's a fascinating side note here. Some historians think that his ideas about white light might have been influenced by his interest in alchemy. Specifically, corpuscular alchemy.
Alchemy. Now that's a whole other rabbit hole.
We'll get to that later. But it shows how his interests were all interconnected in this fascinating way. Now, another important thing Newton did was work on something called Newton's rings. You know those colorful patterns you see when a lens is pressed against a flat surface?
Vaguely.
Well, in 1671, he studied these rings meticulously. And he came up with a method to average his measurements to reduce errors. It was a super advanced technique for the time, and guess what? It's still a fundamental principle in scientific experiments today.
So he wasn't just making discoveries about light, he was improving how we do science in general.
Exactly. And he even applied this error-reducing method to his astronomical observations. When he was studying the equinoxes, he used something that historians have described as embryonic linear regression analysis, a very early form of statistics.
Wow, he was way ahead of his time. So what else did he discover about light?
Well, he showed that if you shine separated colors of light onto objects, the colors of the objects don't actually change the color of the light itself. It supported his theory that color is the result of objects interacting with light. They absorb certain wavelengths and reflect others. We call this Newton's theory of color.
It makes sense, yeah.
His 1672 paper on this was a huge deal. It completely changed how people understood color and vision. And his understanding of light also led him to realize something crucial about telescopes.
Oh.
You know, back then, telescopes use lenses to focus light. They're called refracting telescopes. Newton realized that because lenses bend different colors of light by different amounts, something called chromatic aberration, those telescopes would always have some level of distortion and blurring.
So what did he do about it?
He invented a better telescope. Around 1668, she built the first working reflecting telescope. It used mirrors instead of lenses, which got rid of the chromatic aberration problem. He even presented this telescope to the Royal Society in 1672.
The man was on a roll. So he went from figuring out the nature of light to inventing a new kind of telescope. Pretty impressive.
Very impressive. But he wasn't just an experimenter, he was also a theorist. He developed his own theory about what light was made of, the corpuscular theory.
Corpuscular theory.
He said that light was made up of these tiny particles, or corpuscles, that traveled in straight lines. But to explain things like reflection and refraction, he had to give these particles some wave-like properties too. It was almost like he was anticipating the wave-particle duality that came much later in physics.
That's incredible. He was thinking way outside the box.
He was. He even came up with the idea of a luminiferous ether. You know, this invisible substance that supposedly filled all of space. He thought it was the medium through which light traveled.
Like light waves rippling through the ether.
Exactly. But later on, he seemed to move away from the ether idea and towards the concept of occult forces acting at a distance. It might have been influenced by his interest in alchemy and Hermetic philosophy.
Okay, so the alchemy thing keeps popping up. We'll definitely have to explore that more.
Yeah, well, but back to optics. In 1704, Newton finally published his big book on the subject, Optics. It laid out his corpuscular theory in detail and included these thought-provoking queries at the end. He speculated about the nature of matter, the possibility of light and matter transforming into each other.
Really? Transforming into each other?
Yeah, wild stuff. He even introduced the concept of a black body, which is an object that absorbs all light that hits it. And his inquiries didn't stop with light. He also experimented with electricity.
Oh.
He built one of those early electrostatic generators, you know, the kind that makes sparks. And he showed that electric forces could pass through glass. He even had this idea that maybe reflection and refraction were caused by short-range forces between light and matter, kind of like an early version of field theory.
He was connecting electricity to light.
He was. He thought electricity might be a fundamental force in nature, even in the human body. And get this. In optics, he was the first to demonstrate how a prism could expand a beam of light and how to use multiple prisms in arrays. These are techniques that are absolutely crucial for tunable lasers today.
Wow, so his work on optics had a huge impact on future technologies.
It did. But of course, science keeps moving forward. Later on, scientists like Thomas Young and Augustin Jean Fresnel developed the wave theory of light. Even Johann Wolfgang von Goethe, the famous writer, criticized some of Newton's ideas about color.
So Newton's ideas weren't the final word on light.
Nope. But they were incredibly important for paving the way for future discoveries. And then, of course, there's this story that everyone knows, the apple and gravity.
Yes, the falling apple. It's almost too perfect, isn't it? Like something out of a movie.
It's become legendary. Newton himself told the story of how he saw an apple fall from a tree and started thinking about what made it fall. This story was made famous by his niece, Catherine Barton, who told it to Voltaire, and then, well, it became a classic.
But did the apple actually hit him on the head?
That part's probably a myth, but the core of the story seems to be true. According to William Stokely, who interviewed Newton later in life, the apple falling really did make him wonder about the force of gravity.
Okay, so he sees this apple fall, and it makes him think, why does it always fall straight down? Seems like a simple enough question.
Right. But Newton's mind, it didn't stop there. He started wondering, could the same force that pulls the apple down also affect the moon? Could it be what keeps the moon in orbit around the Earth?
So he was connecting earthly gravity to the motion of celestial objects.
He was. He even thought that maybe this force weakened with distance, following what we call an inverse square law. Basically, the farther away you are, the weaker the force gets.
I mean, talk about a leap of imagination to connect a falling apple to the moon. But didn't it take him a while to develop this idea into a full-fledged theory?
Yeah, it did. It took almost 20 years of intense thinking and mathematical work. He got back into celestial mechanics in 1679 after some letters with Robert Hooke, and then a bright comet in the winter of 1681 really sparked his interest.
So all these things kind of came together to push him towards gravity.
They did. And finally, he managed to prove mathematically that planets move in elliptical orbits because of an inverse square force pulling them towards the center. You know, like the sun's gravity pulling on the Earth.
I see. So he cracked the code, mathematically speaking.
He did. He shared his findings in a short work called De Motu Corporum in Gyrum, which basically means on the motion of bodies in orbit. That was in 1684. And that was just the warm-up act.
The warm-up act? What was the main event?
His masterpiece, the Philosophiae Naturalis Principia Mathematica. We usually just call it the Principia. He published it in 1687. And a big shout out to Edmund Halley, who encouraged him to write it and even helped him financially.
Edmund Halley? Like the comet guy.
The one and only. Anyway, the Principia is considered one of the most important scientific books ever written. It's where Newton laid out his 3 laws of motion.
Oh, right. Those laws are still taught in physics classes today.
They are, and for good reason. They're fundamental. There's the law of inertia, which says that an object at rest stays at rest, and an object in motion stays in motion at a constant speed and direction unless acted on by a force.
Right, right.
Then there's the famous EFMA, the relationship between force, mass, and acceleration. And finally, there's the law of action and reaction. For every action, there's an equal and opposite reaction. These laws revolutionized how we understand motion, how objects interact with each other. They were essential for the Industrial Revolution and are still the basis of classical physics.
Okay, so the laws of motion are big, obviously, but what about gravity?
Well, the Principia is where he formally presented his law of universal gravitation. And this is huge. It was the first time someone unified a force that we experience here on Earth with the motion of the planets and stars. He showed that it was the same fundamental force at work.
The same force that pulls an apple down also keeps the planets in their orbits.
Exactly. Newton's law of universal gravitation says that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers.
So the more massive the objects and the closer they are, the stronger the gravitational attraction.
You got it. It was a brilliant synthesis of physics and mathematics. And he didn't stop there. He tackled the two-body problem, which is about how 2 objects orbit each other under gravity. And he even introduced the 3-body problem, which is way more complex and is still a challenge for physicists today.
So he laid the groundwork for centuries of research on gravity.
He did, and the Principia was packed with other incredible stuff too. He had this almost calculus-like geometric method of analysis. He calculated the speed of sound in air, figured out that the Earth is slightly flattened at the poles because of its rotation, explained why the equinox is precess.
Hold on, precess. What does that even mean?
It's a slow wobble in the Earth's axis of rotation. It takes about 26,000 years for the axis to complete one wobble. And Newton explained it using his theory of gravity.
Wow, I never knew that.
He also did some pioneering work on the moon's motion, which is incredibly complex because it's influenced by both the Earth's and the sun's gravity. He even developed a theory for how comets orbit the sun.
The Principia sounds like a truly groundbreaking work. It must have taken a toll on him.
It did. His biographer, David Brewster, even wrote that the sheer mental effort of applying his theory of gravity to the moon's motion noticeably affected Newton's health.
Wow. So what did Newton himself think about the center of all this gravitational action?
Well, he believed that the center of gravity of the whole solar system was the true center of the world. And the center, he said, was either completely still or moving at a constant speed in a straight line.
Okay, I'm following. But his idea of gravity acting at a distance wasn't that controversial. Like, how could something exert a force on something else without touching it?
Yeah, some of his contemporaries weren't happy about that. They accused him of bringing back occult agencies into science.
Like spooky action at a distance.
Basically. But Newton, he had a response. In the second edition of the Principia, he added his famous declaration, hypotheses non fingo.
Which means?
I frame no hypotheses. He was basically saying, look, I've derived my law of gravity from observations and math. I'm not making up stories about what causes it. I'm sticking to what we can actually measure and prove.
So he was all about sticking to the observable evidence.
Absolutely. It became a cornerstone of the scientific method. And after the Principia, Newton's fame skyrocketed. He became an international celebrity in the world of science.
I can imagine. And even though he was getting older, his intellectual curiosity didn't fade.
Not one bit. He kept exploring. In the 1660s and 1670s, he got really into cubic curves. You know those curvy lines you get from certain equations?
I vaguely remember those from math class.
Well, Newton managed to identify 72 out of the 78 possible types of cubic curves. It's an incredible feat. It was later completed and proven by the mathematician James Stirling, who used a manuscript that Newton had left unpublished.
So even his unpublished work was influencing math centuries later.
You got it. He also turned his attention to heat and energy. He formulated Newton's law of cooling in 1701. It describes how an object cools down over time.
Okay, I can see how that would be useful.
And remember the Principia?
Of course.
Well, in it, he introduced the concept of a Newtonian fluid. It's a fluid whose viscosity, its resistance to flow, stays the same no matter how much force is applied. And he also came up with his law of viscosity, which explains the internal friction within a fluid.
He really was a master of multiple disciplines.
He was. And what's fascinating is that in later editions of the Principia, he added a whole section about the philosophy of science. He talked about his hypotheses non fingo idea and emphasized that we should derive scientific knowledge from observations and generalize through inductive reasoning.
So he was shaping how science itself was done.
Exactly. His emphasis on meticulous experiments, detailed notes, precise measurements, developing testable theories, and documenting everything carefully, it all laid the groundwork for modern scientific practice. He even gave 4 rules of reasoning in the Principia that are still considered fundamental to scientific thought.
Okay, so he was a scientist, a mathematician, and a philosopher of science. But wasn't he also deeply religious?
He was, but his beliefs were, well, let's just say they weren't exactly mainstream. He spent a lot of time studying religious texts and theological questions. In the 1690s, he even wrote about his critique of the Johannine comma, which is a disputed passage in the first epistle of John.
So he was engaging with biblical scholarship.
He was. And get this, he served 2 terms as a member of parliament for Cambridge University. First from 1689 to 1690, and then again from 1701 to 1702.
Isaac Newton, the politician. What was that like?
Honestly, he didn't seem to do much in parliament. The most famous anecdote is about him complaining about a cold draft in the chamber. But he was more involved in university affairs. There's a story about him telling off some students who were spreading rumors about a haunted house on campus.
So he was keeping those students in line.
He was. But then in 1696, his life took a big turn. He moved to London to become the warden of the Royal Mint.
The Royal Mint, as in where they make coins.
That's the one. He got the job thanks to Charles Montague, who was a powerful figure in the Treasury.
So Newton, the scientist and mathematician, was now in charge of money-making.
Exactly. And he took the job very seriously. He oversaw the Great Recoining of England, which was a massive project. He was also promoted to Master of the Mint in 1699, a position he held for the rest of his life.
Did he miss being a professor at Cambridge?
He must have to some degree, but he was clearly committed to his new role. He even resigned from his Cambridge duties in 1701 to focus on the Mint. He was incredibly diligent. He led investigations into counterfeiting, personally gathered evidence, even going undercover sometimes.
Wow, Isaac Newton, the undercover agent.
He was quite a character. He conducted cross-examinations and successfully prosecuted 28 counterfeiters. His work significantly improved the security of British currency. He also made sure that the coins were more accurately weighted and introduced a system of quality control called the trial of the picks.
He was a reformer, too.
Absolutely. And his efforts paid off big time. His reforms at the Mint are estimated to have saved the Treasury a huge amount of money, something like £41,510.
Wow, that's like a lot of money, even today.
It is. And all while he was running the Mint, he was also president of the Royal Society, starting in 1703. But there was a bit of drama there, too.
Always drama with Newton, it seems.
He had a long-running conflict with John Flamsteed, who was the Astronomer Royal at the time. It was about the publication of Flamsteed's star catalogue. Newton wanted to publish it before Flamsteed thought it was ready.
So a clash of egos.
You could say that. And then, in 1705, Queen Anne knighted him.
Sir Isaac Newton. That has a nice ring to it.
It does. While his scientific achievements were definitely worthy of a knighthood, some people think that political reasons also played a role.
So it was maybe a way for the Queen to gain some favor with such a prominent figure.
Possibly. A few years later, in 1717, a report Newton wrote for the Treasury led to a big change in the value of gold and silver coins. It essentially put Britain on the gold standard.
The gold standard.
It meant that the value of the British pound was tied to the price of gold. Historians still debate whether this was Newton's intention or just a side effect of his recommendations.
Even his work on coinage had far-reaching consequences.
It did. And like many people at the time, he invested in the South Sea Company, which was this big trading company.
Uh-oh. Didn't that company go bust in a spectacular fashion?
It did. Newton lost a lot of money when the South Sea bubble.